Good afternoon, everyone. Stephen Elliott of Coherent Breathing. A new video on the heels of last week's. This time looking more deeply into the phenomenon of the complex Valsalva wave featured in last week's video. Today we'll look at the component parts of it, which consist primarily of two. That is the heartbeat and heart rate changes that are occurring. That's along the top of the red wave, where we see spikes from left to right, changing in both amplitude and blood volume. These are heartbeats varying in blood volume and time. And the second primary feature is what is going on as a consequence of diaphragm movement or breathing. The red and blue graphs in the lower panel of the graphic pick the wave apart such that we can see the heart rate independently, that being the blue graph, and the blood volume wave, that being the Valsalva wave, the red wave. And we can see here that they are nominally 180 degrees apart. This alignment is the formal definition of resonant breathing. This was put forward 25, 30 years ago now by Paul Lehrer and Evgeny Vashilov of Princeton University. So here we can see resonant breathing producing this alignment, specifically coherent breathing instrumented at the earlobe using the coherence instrument Valsalva Wave Pro. So this is a view of blood volume and heart activity as viewed at the capillary circulation in the head. This is important because a key reason why the physiology of the human body is arranged as it is to aid in moving blood upward against gravity. If we fail to breathe with depth, that is, if we fail to inhale with depth, it fails to generate a sufficiently negative pressure in the thoracic cavity, what I've referred to as the thoracic pump, and consequently blood volume in the venous tree languishes and fails to flow upward, filling the lungs with blood as it does when we inhale with significant depth, employing our diaphragm to do so. So during inhalation, a volume of blood flows upward from the extremities, filling the lungs with blood, meeting with air flowing in to the lungs via the conducting airways, the blood becoming oxygenated such that when we exhale, the lungs shrink of their own elasticity, ejecting the blood from the lungs out through the left heart into the aorta and ascending aorta and upward to the brain where it's distributed via the carotid arteries. So this is the imperative. This is why resonant breathing does what it does. It generates this wave in the circulatory system with each breath, and the function of the wave is to move blood in the body upward against gravity, even when we are not exercising, as it does out of necessity to generate energy for exercise. So here, if we think about being seated as I am now, or standing, or walking around, or working in an office or other workplace where we're erect much of the day, breathing slowly, deeply, and rhythmically facilitates circulation and the advantages accrued from increased circulation, even when we are not actively exercising other parts of our body. For example, running. So I've always considered this to be really a fundamental premise of resonant breathing and coherent breathing in particular is that we're gaining the advantages of exercise even when we are going about our daily activities that may not be involving rigorous activity. Does that make sense? Thank you for your time and see you next week.